Hello problem solvers, Colfax Math here. Today I was going to talk about conic sections. It's a branch of mathematics that's really cool. It's super cool how the conics are actually formed, and then there are millions of applications. Well, maybe not millions, but a lot of applications in the real world. So a conic section is formed by you start with a cone or even two cones end to end and a plane, and then you take that cone and that plane cuts straight across that cone. So there's an axis going down the center of the cone here. And if that plane comes right through and cuts right across that cone like that, it gives you the first conic section, and that's a circle. So the equation of a circle is x squared plus y squared equals r squared. Another scenario is the plane is actually at an angle. So the plane comes in at an angle this way, cuts across the cone, and that gives you an ellipse. And an ellipse is really just a circle that's been dilated in a different amount in the x-axis versus the y-axis. It's like a circle, except it's been pulled more or less in one of the directions. The third conic is a parabola. So the plane comes at an even steeper angle, and it cuts a cone like this. And that gives you a parabola. The equation for a parabola, if it opens up, is y equals x squared. If it opens to the side, x equals y squared. A lot of applications of parabola, from your satellite dish to your headlight. The fourth conic is if you have this cone and another cone on top of it, so like this, it gives you what's called a hyperbola. And it would be this one and then the one on the top cone up above. Radio signals travel in hyperbolic paths, like the Loran system for navigation that they built just after World War II. A hyperbola would have the equation something like x squared minus y squared, and they'd have dilations underneath them equal to 1. So that's what conic sections are. Let's take a look at some of the general equations for these conics. Conic is a circle. Its general equation is x squared plus y squared equals r squared. R is the radius of the circle. So if I had a circle, say, with a radius of 5, that equation would be x squared plus y squared equals 5 squared, or 25. Second one is an ellipse. If I have the x-axis here and the y-axis here, so the A and the B underneath it change the amount of dilation or opening in the x direction and the y direction. So if I had, say, a hyperbola like x over 5, quantity squared, plus y over 3, quantity squared, equal to 1. Let's say y is equal to 0. When y is equal to 0, this whole thing turns into 0. When will this be 1? Well, it would be 1 at 5 and negative 5. So I could see this would be at 5, at negative 5 and at 5, because if I plug that in, negative 5 over 5 is 1. Negative 1 squared is 1. 1 equals 1 when y is 0. Or when x is equal to 0, this whole thing would be 0, and I can see it's going to cross the y-axis at 3 and negative 3. So we have a circle, an ellipse. The third conic is a parabola. Again, if I had a y and an x-axis here, the parabola that opens upwards like this is y equals x squared. The one that opens down would be y equals negative x squared. One that opens to the right would be x equals y squared. And the one that opens to the left would be x equals negative y squared. So identifying them, figuring out what they look like and knowing where they come from is really a big part of them. And then the fourth conic is a hyperbola. It's these two arcs like this. They're actually not arcs because they're not parts of a circle. And a hyperbola is really the same as an ellipse, except it has a subtraction sign instead of an addition sign. So it's going to be x squared minus y squared, opening side to side, or negative x squared plus y squared, opening up and down. You're going to graph it kind of the same way as you graph an ellipse. Instead of the key points, you're going to create these asymptotes that it's going to approach and never touch. So not only do these things dilate in and out, bigger and smaller in x and y, but they can also be moved from the origin. So if you were to move this ellipse over here, that would change the center of the ellipse, just like it would change the center of the circle. And the new center of the conic would be at the point HK. And then the way you would do that in your equation is this would be x minus h, y minus k. And that would put a new center in the ellipse. Same with the circle, it would be the quantity x minus h squared plus y minus k squared equals radius squared. And this is a circle centered at the point HK. Let's say I have a circle x minus 2 quantity squared plus y minus 3 quantity squared equals 36. Everything's on my Cartesian coordinate plane, horizontal axis x, vertical axis y. First thing I do is I find the center of the circle. It's going to be HK. I just read these two values, 2, 3. So I go over 2, up 3. There's the center of my circle. My radius is equal to the square root of 36, or my radius is equal to 6. So if this is 3, here's like another 3. So I'll come down to negative 3. 2 plus 6 will put me at 8. 2 minus 6, negative 4. And then up here, whoops, making a mess here, 9. So that's a circle centered at the point 2, 3 with a radius of 6. An ellipse works similarly. A parabola as well, you're going to have x minus h, y minus k. And same thing on a hyperbola. You're going to have x minus h, y minus k. So that's conic sections, a quick overview, how to identify them, how to kind of sketch them, getting a feeling for what a conic is. There's a lot of really good algebra that goes along with them, but I think I'll put that off for another video.